the director of Spaceport. And we thank him for supporting the lecture series, but also for all he's doing for the city of Houston too. So, we're in a bit of adjustment right now, so I don't have an announcement for a speaker for next month, but we are looking at someone, and we have a tentative speaker for April that I won't announce because it depends on what NASA does with the schedule. But we are very privileged and honored to have tonight's speaker. Many of you might know Steve Rader. He is a Rice graduate, but we don't just pick people who are Rice graduates, even though they have to be the better ones. But Steve has been, in Scotland, a well-known face. People know Steve for a lot of the work he's been doing over the years, and so really, really great to have him here tonight. So I have to do the official thing because there's a lot of stuff in his resume. So Steve currently serves as the program manager of NASA's Center of Excellence for Collaborative Innovation, COECI. And I can help you with those acronyms.
It's okay.
And the NASA Tournament Lab, NTL. And these two facilities are working to infuse challenge and crowdsourcing innovation approaches at NASA and across the federal government. There's a couple more sentences about what that is, but Steve is going to tell us exactly tonight how NASA is engaging in the innovation system in Houston and more broadly. Steve has worked with various projects and organizations to develop and execute over 100 different challenges. He speaks regularly about NASA's work in crowd-based challenges and the future of work both publicly and internally to NASA workforce to promote the use of open innovation tools. And if you haven't been following it, Houston is developing a much better infrastructure for innovation than we've had for many years. And maybe Steve will touch on that too. He has a mechanical engineering degree from Rice University and has worked at NASA's Johnson Space Center for 33 years. Prior to joining COECI ATL, Steve worked in mission control, flight software development for the Space Shuttle and International Space Station, command and control system development for the X-38, and led the command and control communications and information, C3I, acronyms, NASA, you get it. So the C3I architecture definition for the Constellation program. Well steeped in the history and recent history of what's going on at the Johnson Space Center, and then taking them up into the 21st century. So, Steve, I'll pass it over to you. Please join me in welcoming Steve.
Well, thank you, David. That was very kind. It's great to be back on campus. I graduated in 1989. I was at Weiss College when it was simply a Motel 6 design of temporary housing from World War II. So the campus has changed a lot. I try to visit quite a bit, but it is great to actually come back and speak at your own university. So it's kind of nice. So I'm going to talk about something you may have heard some about, and it may be brand new to you, but I think you'll find this a little bit interesting of what we've been doing and what is happening really across all industry. It's this idea of solving problems using the power of the crowd. Just briefly, as we said, the organization I work in, COSI is actually how we say that, is a center of excellence that works across the entire federal government as well as within NASA. So it's kind of a dual-use center of excellence. That came about in 2011 when the Office of Science and Technology Policy at the White House saw what was happening in open innovation, really wanted the rest of the federal government to get engaged, and NASA had done some work in this area and knew what they were doing, and they said, hey, you guys know what you're doing, can you help the rest of the federal government by standing up a center of excellence? And so that's kind of the history behind that. At NASA, we're facing lots and lots of challenges, right? There's a reason we're not all living on the planet Mars. It's because it's really hard and it's really expensive, right? And we have all of these challenges that we're trying to solve. And so we need better ways to innovate. And I say better because over the last 30 years as I've been at NASA, the world has changed. Now, this is no news to you, right? You hear this every day that the world has changed. But this is a talk I give to our workforce because everyone knows it, but let me just kind of put out there that you may not know it. The things that have worked for 20, 30, 100 years are starting to break because we're getting to this point in history. I'm going to start with population just because it's this really nice exponential curve. But this is the start of the Common Era, and the first doubling of the population took 1,400 years. But in my lifetime, the last 50 years, the population has more than doubled. We're in a part of the curve that is new, to say the least. And that has implications because over the last 20, 50 years, not only has the population grown, but countries have become wealthier. And they've stood up lots of universities, and there's a lot more technology out there, to the point that in the last 20 years, the number of students that have graduated from secondary education has over doubled. That's huge. So think about all of the scientists that developed all the curriculum that you're familiar with, right? All of those dead scientists, right? There's a couple of those that are still alive, but most are dead. Okay, that's over all history of mankind. If you took them all and added them up, you would find that over the past 20 years, we've changed such that 90% of all scientists that have ever lived on planet Earth are alive today. 9 times more scientists are alive today than ever in the history of the world. And so when you hear about the technology explosion that's going on out there, realize it's tremendous, to the point that the patent system's starting to break. It used to be a couple 100,000 patents a year. In 2017, it blew past 3 million. If you look at numbers of PhDs, a similar curve. If you look at how much the dollars going into research, it's a similar curve. If you look at Moore's Law, it's a similar curve, right? You get the idea. And what's interesting is this technology explosion is accelerating this rate of change. It's not that technology's new and that change is new, it's the rate. It's just gotten to be so quick. And one of the things that's really interesting is that out of all this technology explosion have kind of emerged these really cool building blocks. Things like 3D printing, things like blockchain, like software APIs, like machine learning, even things like CRISPR, which is gene editing. These are all technologies that many of them are very inexpensive to learn. In fact, somebody told me the other day they took their kid to the Children's Museum and their 8-year-old learned how, it was a science museum, sorry, learned how to extract DNA. An 8-year-old. CRISPR, by the way, it's like a $200 kit and you can edit genes. That should scare everyone. But the whole idea here, these are inexpensive to learn and to buy. You can buy a metal 3D printer that can do high resolution parts for under $10,000. That's like a factory used to be able to do that. And now you can buy that and do that in your garage and make money. It's a really interesting time where these things are accessible, they're inexpensive, but the most important thing is that almost all of these technologies aren't in one industry. They're applying to every industry. So think about that for a second. That's a new playing field. We used to have technologies were growing largely in one industry. There's somewhere across all industries. But if I were to take these and I plot them, right, where I plot all the industries along the bottom here and across, as we go up, we get more complex, right, the depth of that. Then my industry would be, one. So space would be this one little dotted line. And if I were to look at something like machine learning and what's going on there, I would see that in my little sliver, I've got a lot going on. I've got some stuff just starting, but I've got some really mature stuff as well. But so does everyone else. Everyone's doing something in machine learning. Now this one dot this over to the right, it's kind of high, that's probably John Deere. I don't know if you know this, but John Deere is one of the leaders in machine learning in the world. They make mini factories on wheels that make their way through farmland. But if I went to that meeting where they were talking about that AI program that they have going, they would use jargon that's specific to farming. They would be talking about a problem specific to farming. And I could sit through that entire presentation and not realize that that technology could actually apply to space. You just can't. How do you do that? So we're kind of in a conundrum because this technology explosion, which is causing all this technology to be used across different domains and then develop and kind of pair with and morph with other technologies in each of those domains, is creating lots and lots of solutions. And so the pro is, at no other time in history have there been so many technologies that are sitting there that are potential solutions to hard problems. The con is that you can't find them. If you think you can Google the latest and greatest technologies and then go build on them, then you don't understand this problem. These technologies are sitting behind IP firewalls, they're sitting around the world in labs, they're in other contexts, in other industries where you don't understand the lingo, you don't understand the problem, you don't understand their solution. And that's kind of a tragedy in some ways, right? When I was an engineer growing up, we would just talk to some old engineers and go to a couple conferences and talk to some vendors, and we would be able to pick a technology that was the latest and greatest, go and develop something over the next 3 years and spend millions of dollars, and at the end of that, deliver that to the space station or the space shuttle, and that would still be the cutting edge. Our solution would still be the cutting edge. That's not the case today. If you don't find the cutting edge, the real cutting edge, you're going to get halfway through that project and realize, oh my gosh, somebody's got not just a better solution, a 10x better solution, and now I've got to pause and I've got to throw away that work. Okay, so we're in this kind of state. And now on my screen, this is just screaming past me because this is my panic slide. Because the rate of technology has gotten to the point that the knowledge in the technology is increasing at such a rate that it's really hard to find skills, people with skills, right? You talk to HR all over the country, all over the world, and people are having a hard time finding the right skills. But it's also hard to keep up with the advances. And the result is there's this high risk of remaining competitive and irrelevant. And in fact, NASA is one of those organizations. We used to always be on the cutting edge, but there's a threat, right? There's a bunch of commercial folks doing stuff. There's a bunch of governments around the world, India, China. Everyone's got a space agency now. And if they start delivering solutions that are more cutting edge than what we do, you guys are going to ask, why do we need NASA? Right? You should, as a good voter. And so it's important for us to innovate. But it turns out it's not just important for us, it's important for all business. And if you look, this is kind of a dated slide. I think it's actually gotten worse. But this was a study, it was a few years ago, that said in the past 15 years, from when the study was, 52% of Fortune 500, the most successful companies, had gone extinct. And if you looked at the average lifespan of companies, in 1935, it was 90 years. In 2018, that was down to 18 years. I think it's down to about 14 now. That's the average lifespan, not of all companies, no, of our most successful companies. This doesn't even count all of those startups that kind of flare up and go away. So let me just prove my point here a little bit. This is Subsea 7, they're a company here in town and in Europe. They're all around. They support the oil and gas industry, and one of the things they do is they do pipeline bundle inspection. So pipelines that go from oil rigs in the Gulf or wherever to shore, and they'll take a ship out at $1 million a day, and they'll lower a minivan-sized piece of equipment next to that pipeline, and they'll run that for about 2 weeks to scan that pipeline bundle and inspect it for cracks and problems. They went to a company that I'm going to talk about, this class of companies, these crowdsourcing, open innovation companies, and in 2 weeks, they found that there was a technology that could do that same job, and it was in the mining industry, already being used, could do that same job in 2 hours and was handheld. Yeah, So this is 100 times better, right? They're going to make bank on this, right? But you know what they said? If we had not found this technology that was in use in another domain and our competitor had, we would no longer be in this business. So if you want, this isn't the only reason that companies are going extinct, but you can kind of see if you don't stay up with technology, you will be disrupted. So let's come back to the chart. I love this chart. I don't know why, but this is NASA, right? So this is our slice of heaven, and we hire people in this bubble, right, with the skills that NASA needs, and we only start at a certain level because we have standards, right? We only get people with good grades coming out of school, and we can't actually afford the people at the top because we're the government and we don't pay very well, right? So this is our box of people. If there are all these ideas or these technologies or these solutions that are sitting out there across the domains, if I put one person to work and say, go innovate, they're going to be able to innovate. They'll access some ideas, but they'll have limits to that because of the context, because of their knowledge, because of where they are. If I put a team on that, team's always going to do better. Teams always outperform individuals. Turns out, though, if I put the crowd on this, the crowd acts as a dragnet across all industry and all domain. It's this kind of statistical magic that happens when you actually access crowds to do this. So this all started back with Alf Bingham, who was a scientist who had noticed that a lot of the best innovations were coming not from experts. And he had noticed this when he was coming up through university and was in labs. And when he went to work for Lilly, Eli Lilly, he went to the chief scientist and said, look, I see we have these 20 unsolved problems that our scientists have been working on literally for years as their pet projects. I want to take those problems, I'm going to put them up on this website and just see if someone else has a solution. So he does it. He gets permission, does it. The next day, there was a queue of 20 scientists outside the chief scientist's office saying, you need to take these down. We're the only ones that can solve these problems. You hired us because we're the experts. Take these down. You're going to give away all our intellectual property. Take them down now. And they took them down. Eli Lilly goes back into the office and says, hey, look, this is all smoke and mirrors. Trust me, this is worth it. We're not going to give away, kind of work the whole intellectual property thing. We'll talk about that at some point. Convinced them to put them back up. 2 months later, I think it was about 2 months later, 19 of those 20 problems had been solved by people who just wanted to work on them. That was the start of Innocentive, which is a crowd that's now Wazoku Innocentive. But it's about 500,000 scientists and engineers who 75% have higher level degrees that solve problems. They're the people you know that always do the crossword puzzles and remember all the math from college. You know those people, you hate them, just like I hate them, right? But they get on these sites and they'll spend, an hour or two just trying to solve problems. And when they solve them, they get a prize of $50,000, $100,000, $10,000. It just depends on the problem. It's a really interesting model. And it's what we call open innovation. Open meaning going outside your traditional team, right? Your traditional set of folks. So that might be going to the whole company outside of your small team, or it might be going to the entire world. And it turns out this is a really kind of the tool to solve the problem, right? Just at the time that the world's having this problem of finding these technologies when they need them, the crowd emerges as this tool. So it works a little bit like crowd platforms you're familiar with, right? Which provide this low friction matching at scale. That's a great way to think of it because you're trying to find a solution to a problem, right? And you're trying to match that. Much like Uber, right? Uber is trying to match someone who needs a ride and someone who has a ride. And they do that very friction-free, right? You click a few buttons and somebody shows up, you get in the car, you get out of the car when you get to your destination, and you barely have done anything. it's kind of magic, right? Airbnb, same thing. You find a place, you go, you don't have to talk to anybody. The interesting thing too, by the way, is they built not only a low friction matching scale, they built in trust. Like, does anybody remember when Uber came out? What was the first thing that went through your head? Is it safe? There's no way I'm getting in with some crazy person. First time you heard about Airbnb, ooh, that's gross. Why would I ever sleep in someone else's bed? And now we have no problem with it, right? So these kinds of platforms are not new, but what you might not realize is there are lots of these platforms that are doing things that you don't necessarily see in the consumer side. These are what we call curated communities. They have two sides. One side is the crowd-facing side, and the other is kind of the customer-facing side. On the crowd side, they're basically getting members to sign up, right? So you're going out and you're advertising. So Top Coder, 1.6 million software engineers and data scientists. So they've appealed to them to meet up with other people that have that passion, to learn new things, to try out new things. And people have come to the tune of 1.6 million, right? So these aren't the people that are really bad at this, because they actually had enough gumption to sign up on a website and spend time doing code that wasn't in school and not in their job, right? So these are kind of higher end folks. Freelancer, 63 million people in one community, one crowd. That's just shy of 1% of the world's population. GrabCAD, 11 million mechanical engineers and designers on one platform, just there to learn new stuff and trade models. That's all they're there for. There's a passion about it. I talked about the nerds that really like to do the crosswords and solve problems. Agorize, HeroX, Innocentive, Wazoku, HeroX. These are all platforms where literally hundreds of thousands of people are joining just to try to solve hard problems. That's their passion. And those crowds typically aren't like Top Coder, where it's everyone's a software engineer. They actually have a very broad set of skills and folks that are there. Tongle's filmmakers. The customer-facing side, however, is the commercial side. It's the reason they're making money, because they're going to GE and they're going to Procter & Gamble and they're going to General Mills and they're saying, hey, you need an algorithm? You need your problem solved? Just give it to us and some money, and we will get that for you. And they do, very successfully. I mentioned statistics, because this is really hard to get your head around, because doesn't everyone just think it's like some loser in the basement, right? That's whose work. And it's not. It's literally everyone. Most people have jobs, but you can't put them in one category. And it's a lot of people, right? So I hate this slide, because this is Texas A&M. My wife went to Texas A&M, so I've gotten to reconcile a little bit. In fact, she's somewhere in the picture there. But I like I use this picture because this is 100,000 people, right? If I did Rice Stadium, A, it would only be 70,000, and B, it wouldn't be full. But this is what 100,000 people looks like. And it blows your mind, right? Whenever you go, because you can't really comprehend what 100,000 people are. But this is it, right? Now think for a second, what do all these people do? They're all sports fans, but what do? Well, there's doctors and there's software engineers. There's a lot of people here, right? Probably smarter people because they're at a college football game, right? So they probably might have alumni, so they maybe went to college. But it's hard to say, right? If I took that stadium, and this is the layout for that stadium, and I tried to visualize our workforce and kind of assumed this was how that stadium breaks out, then if I put all the civil servants in the stadium, that's how much we would take up. This is all of NASA, not Johnson Space Center. This is all 10 centers, all of the civil servants working on space, and then took all of our contractors, including our cafeteria workers and our lawn workers, and we actually, I think this is a little outdated because I think we aren't 60,000. I think we're closer to 50, 55,000 now. But this is everybody. I personally think the civil servants should have better seats. But that's a whole nother thing too. This is everybody. And I could put it in that stadium, I would only fill it up by 2/3. And if I look at one of our smaller crowds, and I said it was 500,000, but when we were working with them, there were 400,000 people in incentive. That one crowd is 7 times larger than our entire workforce. If I go to Top Coder, closer to 1.5, 1.6 million, that's 15, 16 stadiums. If I go to Freelancer, well, now I'm into 50, 60 million. It starts to get incomprehensible again, right? It actually got incomprehensible early on, right? So the theory goes like this. If expertise is what you need smart people. Okay, so let's say this is quantum physics. Let's say I'm going to go do something with quantum sensors. I need quantum physicists or people that know quantum physics. Then this is what the curve kind of looks like, right? There's a peak at kind of where that is taught the most out in school, so either early college or late high school. And in the general population, then there's the world's experts way out to the right. Does that sound right? It's something like this. Then if you're like NASA, you hire really smart people. And so you don't even start hiring people until the middle of that curve, right? Or the right side of that curve. And at NASA, we actually have some of the world's experts. We just did a challenge the other day with a Nobel Prize winning scientist. It was awesome. But what I tell our folks is, yes, that's exactly right, except we are actually this tiny little blip. The amplitude is much smaller than we think because we're only 60,000 people. And the world's a big place. And so the value proposition for us is how can we find people in the long green wedge, right? People that are as smart or smarter than our workforce. Because this problem needs someone that's smart. And it turns out these curated communities have these people. They're not totally populated. They have a lot of people on the left side of the curve, trust me. But they do actually have some of these folks. And if you look at the theory, when you're looking for valuable ideas, it turns out that traditional experts are great at kind of middle of the road value. And as they go out, you can get even more. It's a different graph. But non-traditional participants can actually get you more value because there's more of them. And the stats, there's a lot of reasons behind it. But this is some work that Harvard did for us. And it's really fascinating. And in fact, MIT went and studied an incentive who had all these successes. And they said, hey, who's winning all of these? And they studied all the winners. And what they found was 70% of the time that someone had won one of these contests and solved a problem, they were not in the same domain as the problem owner. So think about that. If it's a chemistry problem, 70% of the time it wasn't a chemist that solved the problem. Because they're all thinking the same thing, right? They're all trained the same way though. Now they may know some chemistry, but they're working in this adjacent or other domain. And 75% of the time, they already knew the answer before they had seen the problem. In other words, it existed. Like we were saying, it's come up in this other domain, and they just had to connect the dots and say, oh, I've seen the solution to this before. It's just over here. So we see that over and over. Because it turns out that diversity is actually the secret to innovation. Because the same old people working the same old problems are going to hit the same old stops. So how do we do this? Just real briefly, how can you extract from 50 million people answers? Well, it turns out that the magic algorithm is, at this point in time, a contest. Not just any old contest, not just one you can just throw some money out and say, hey, whoever gives me an answer, I'll give you $10. You got to know how to formulate the problem. You got to know how to design the challenge. How many prizes? How big should that prize be? How long should we actually run this challenge? You've got to execute it. You got to have a platform that has access to people. So you got to know how to either market them or you have to have them as members already. You have to filter solutions. We had a contest that had 5,000 submissions. That's a nightmare, except It was with HeroX, and we had in our contract that they could only give us the solutions that met all our requirements. Turned out to be 87 out of 5,000. And then they have to deal with the intellectual property. How do we transfer that over? How do we protect the intellectual property of the competitors? They deal with all of that, and they're really good at it. So let me just give some examples, because this is the cool part. So there was a company, it was a major company, that went to Innocentive, and they came with a problem. They said, look, we need a better way to remove grease from our potato chips. Because what they were doing is they were vibrating the trays of chips as they came out of the vat of oil, and that would shake the grease off, but it would also break some of the chips. And we as humans only really like the big chips. Until we get to the end of the bag, but that's a whole nother thing. So food production engineers are largely mechanical engineers, and mechanical engineers are the world's experts in vibration. Does that sound right? I'm a mechanical engineer, so just believe me. And this is a very mechanical engineering solution, right? Shake the tray of chips and get the oil off. So the first thing Innocentive did is they actually changed the problem statement. Remember I said how you put the problem out there matters. So they, instead of saying, how do you remove grease from potato chips, which quite frankly, if you put out there, would really only be attractive to food scientists and food production engineers, right? They changed it, and they said, no, let's say this. Instead of how do I remove grease from a potato chip, how do you remove a viscous fluid from a delicate wafer? Now, this is a much nerdier way to say it, but what did it do? It did two things. One, it hid the fact that they were a potato chip company. And so that if you were the competing potato chip company, you didn't know that, almost said their name, that this company did that, right? But more importantly, it opened up the problem to almost anyone, right? Because as nerdy as this is, almost everyone can relate to this and knows what it means. And it turned out that the solution that won was really quite clever. It was to acoustically vibrate the air around the chips as they came out of the vat of oil at a resonant frequency to the oil. So that you've seen like big boom boxes where the water dances on it. Same idea. And it turned out that the person that came up with that was a violinist who had seen the rosin dance on her stand when she hit certain notes, understood resonance, understood this kind of phenomenon, but had seen it visually and connected the dots. What kind of solution is this again? It's vibration that the experts remained blind to for how long? I don't know. How long we've been trying to get grease off potato chips. So experts aren't always the gold mine, right? They're important. We have to have experts. But this breadth, this diversity, is a secret for innovation that if we can tap into, is super valuable. Roche Diagnostics was a multi-billion-dollar pharmaceutical company in Europe. You may not have heard of them, but they're very large. They do about $4 to $6 billion of research a year. They had a bunch of problems. They brought them to Innocentive. They were going to try out this newfangled crowdsourcing. And one of the problems was with a in vitro diagnostic machine that they needed to measure the sample inlet intake sample quantity and quality very precisely. They had worked on this problem for 15 years trying to bring this product to market. So they had brought in all sorts of people, all sorts of money, right? They brought it to Innocentive. They posted it on their site for 60 days. And at the end of that 60 days, they had 2 solvers that had actually submitted the same solution because it already existed and they just knew about it. But that's not the cool part. The amazing part was when Roche looked at all of the submissions, they found everything they had tried over 15 years of failure was there, submitted by people that weren't experts in the field. Innovation is a lot about failure. Turns out open innovation, you can get massive numbers of failures for free because you only pay the winner. This is actually why data science works so well, because in data science that you're basically trying to find this right mix of how you cut the data and how you load it, put it with an approach, and then all the different coefficients that you've got to put with it. So it's this big kind of mess. And it turns out that in algorithm work, crowdsourcing is just on fire. Running contests to come up with algorithms is magical because these folks really enjoy it. And what happens is they're all trying to get better and better performance, and the best one just raises to the top through a scoring mechanism. So Harvard was trying to figure this out because they're trying to figure, are we just finding the best data scientists? Or is there something else going on here? So they did an experiment. They actually went to National Institutes of Health and said, hey, we want to run this challenge with your MegaBlast algorithm. So this MegaBlast algorithm would take about 4.3 hours to run, and it was only accurate to about 0.72. The thing about it, that means you can only do about 2 runs per day per machine, right? So not a whole lot of throughput in the lab. They took 2 postdocs that were specialized not only in data science and were top-notch data scientists, but also familiar with this domain. And they gave them a year and $120,000, and they improved it drastically. They got it down to 47 minutes. So now you can do 10-ish runs a day per machine. And they increased the precision, right? So 0.77. This is important. The accuracy, not the precision, sorry. Then they did a 2-week marathon match on Topcoder for a $6,000 prize. And at the end of that contest, they had an algorithm that could run in 16 seconds with an accuracy of 0.8. This is a plot getting faster as you go from right to left and more accurate as you go up. And you can kind of see at the top, there's the big red winner dot, right? 2 orders of magnitude better, 3 orders of magnitude better than the baseline, 2 orders better than the experts. What I like to point out is there's 25 little red dots right next to it that all had submissions that were solutions that were also 2 to 3 orders of magnitude better. 25 other submissions that were all the losers. There's something that goes on in the crowds for crowdsourcing that isn't supposed to replace your innovation. It's the better starting point for your innovation, right? This is where you go to start. Because think about it. How many different approaches? 89. 89 different approaches were identified here. If you know anything about data science, you know that while they got down to 16 seconds, if I know there's 89 approaches, I can get an even better answer. So this is actually the starting point for innovation. So this is our organization. We, again, work across the NASA and all of our centers, as well across the entire federal government. Our name brand that the public knows us as is currently NASA Tournament Lab. We're about to rebrand, but what we do is, as a center of excellence, we help projects, engineers, scientists, people all through government understand these tools. And not just understand them, but use them. So we actually have on contract a bunch of these crowds, and we basically hold their hand, help them formulate the problem, and get it out onto these curated crowds and run these competitions. We work across the entire globe with other governments, with academia all over the world, with companies all over the world. And it's weird, you don't hear a lot about this because it's so many companies' secret sauce. They're not going to tell you about this. This is their competitive edge. But we're the government, and we want everyone to succeed, so we're going to tell everybody, right? And we do. We talk to everyone, we find out what their best practices are, and we try to share those with everyone that we know. We have basically 50 different communities that we can reach out to contractually that represent 200 million people worldwide. And they do different things. Some do video, some do CAD work, some do hard science problems, some do algorithms, others do software. And one of the crowds we use is actually an internal crowd. It's called NASA at Work. Again, we're about to rebrand that, but this is 30,000 NASA employees and contractors that are all on one community, and we post challenges there all the time because we realize as a large organization, everyone's siloed. It's very hard to talk to each other. And so this ends up being one of the best enterprise knowledge management systems we've ever found. Because we can ask a question on the platform and say, does anyone know how to solve this problem? And sure enough, people pop out and can actually find those solutions. And it's actually helped the collaboration a lot because we can now bring people all across the country together or in the agency around one problem. So this is our platform. Just to give you an example, we actually had a guy who was working to get a better way to measure urine in microgravity, because it was a really big machine. It's actually one I worked on, really big, and we have to do a lot of this, and he's just trying to shrink it down. And he went out to the NASA crowd and said, hey, does anyone have a way to do this? And it turned out that 300 yards away from his lab was another lab working on a totally different problem, nothing to do with urine, that had a prototype that could do exactly that. And it saved them years of development and millions of dollars because they had a better starting point. They didn't go fly that prototype. They still had lots of work to go do to make it better and to fit and to make it fly in space, but they had a better starting point. Okay, I'm going to run through a bunch of examples. I hope you don't get bored with this, but they're kind of fun, actually. Innovation, problem-solving challenges. This is what we do most of. We actually worked with the Mars team because it turns out as the spacecraft's coming through the Mars atmosphere in the, 7 minutes of terror or whatever they call it, they actually have, they're in between space and atmosphere, right? So lifting bodies don't work yet, but you can't just use thrusters like you used to. You're in this really weird space. So you know what they use to change the trajectory slightly? They eject. If you look, you can kind of see it right there. There are these little blips that fly out. They're basically using balloon technology from the 1800s. They're basically ejecting masses of tungsten, and when they eject it, it slightly adjusts the attitude of the spacecraft. And what they wanted to know is, we're taking heavy little mass all the way to Mars, which is really expensive, and just throwing it away. Isn't there something we could do to give us some scientific return? And they'd been thinking about this for years. And it turns out that there was an engineer that's from Rising Star, Texas, population 800, who worked in the oil field, who came up with this idea. It's like, look, what if we make it out of barium? And when you eject it, it'll dissolve the atmosphere, and you can use one of your orbiting mass spectrometers to analyze it as it dissolves and actually see what's going on in the upper atmosphere. Space poop challenge. You have to realize, NASA, we have a lot of bodily fluids that we have to deal with, a lot of all the things, right? It's kind of icky and gross. I used to be life support. My first job was to work on the space potty. But you have to do this because weightlessness has different needs. So we actually had the Orion program come to us and say, hey, look, when we launch and go to the moon and do the burn to go to the moon, the backup for if we get a cabin leak and we start bleeding pressure is to get into our orange launch and entry suits and live, which is fine, except it takes 4 to 6 days to make it all the way back. And so you're living in a pressurized garment with all of your carry-on baggage. And so we did a challenge, said, is there a way to deal with this? This is the one we got 5,000 submissions, by the way. And it turned out we had some really amazing submissions. The winner was actually a flight surgeon from San Antonio who was very familiar with pressurized flight suits and actually built a bunch of prototypes. But the key one that won it for him was he said, in laparoscopic surgery, we pressurized the belly to about 15 psi, which is actually more than the delta pressure we have in the suit. And he says, we insert this little airlock that allows us to pass wipes and instruments back and forth between the two pressure sides. That was exactly the kind of thing we needed, right? So again, finding these better starting points, these novel approaches from other industries. Technology search, this is finding companies that are out there. There are so many companies now. We find that we actually can't find them all. The Lander program was looking for better sensors, and we actually used Yet2 for a couple of searches where we ended up finding, for 3D terrain mapping, LiDAR sensors, 8 different technologies we didn't know about. If you're an expert in something and you don't know about 8 different, not companies, technologies, right? And the same with automotive systems. We went to see there's a lot going on in automotive sensors. Sure enough, 9 technologies that we thought might actually help us. And again, these are $20,000, $30,000 searches, not a lot of money to actually get started and get a better starting place. I've mentioned data science just to give you some idea of what we've done. Predicting solar flares is really important, especially if you're out at the end of the solar arrays on space station. You've got to get all the way back. We had about an hour and a half, 2-hour prediction capability that, hey, a solar flare is coming, you need to get inside. That was cutting it really close. So we're trying to double that. We put a challenge out on an incentive. 60 days later, we actually had a solution that could actually predict 8 hours ahead. And it was by somebody who was a cell phone engineer who happened to have a heliophysics degree that he had just taken for fun that he had never used. And it turned out that there's some math in signal processing that's used for cell phones that, when applied, heliophysics gives you a really great prediction for solar flares. Again, you're looking for those people that you would never hire because you wouldn't know how to describe the job. Asteroids, the real thing that's going to kill us all. We have to find these things. They're very dark, they're very small, and so we did a challenge around this a few years ago. And we actually, at the end of the challenge, had to improve the state of the art of finding these really hard to find asteroids by about 15%. But we also packaged that up into a downloadable app for amateur astronomers so that more people could be looking at the sky, and we would increase our odds of actually finding asteroids. Software challenge, a lot of people don't realize you can actually use crowds to do this. There is open source, which is a model of this, but in the contest world, Topcoder's been really amazing at getting the entire software development lifecycle. They break it up into lots of little challenges, and each one, they're actually tapping into a slice of expertise. So they'll run a challenge on user interface and get just the best user interface folks, or do one on testing and get just the best testing. And we've done that for iPad apps that the crew uses to actually track all of their nutrition. And that flew on space station for a long time and won the Apple App of the Year. These are things where we just work with crowds to provide things that we need. The first thing the crew said when we actually showed this to them, hey, this wasn't developed at NASA. This actually looks pretty slick. This wasn't done by civil servants. This is done by people who know what they're doing, right? Which NASA people know what they're doing. We're just not very user-friendly. Like, we're kind of nerds in that. This was the infographic on that. It actually was 21 different challenges engaging over 55 people with 99 different submissions. You can kind of get a feel for how that works. Creative design. This can be anything from graphics to CAD. We find this to be a really great way to engage the public. It turns out that over the past 50 years at NASA, we've gotten really good at basically telling the public, look at this cool stuff we're doing. Don't you wish you were us? And what we're trying to do is say, hey, look at this cool stuff we're doing. Can you help us? Be part of us. Be part of the solution. We run a bunch of graphics contests where I'll get emails that say, you've made my dream come true. I've always wanted to work at NASA, and I got to do that by just submitting to this contest. So we do a bunch of graphics and patchwork, but we also do design work. We've done just some remarkable things for not a whole lot of money from our side that we wouldn't have been able to do otherwise, that engages a lot of people and discovers, again, better starting points. We actually did a smartwatch app where we did some design here that would give the crew kind of, here's what your communication status is, here's what your timeline, and some tools like that. And really, for under $5,000, we're able to get this amazing design and have someone prototype it. which is crazy. But it was kind of a win-win for everyone because somebody got to go home and say, hey, I built this app. I can build something for you. It turns out that once you've done something for NASA, you can use that to get your credibility way up and make a lot of money. But that's another story. This was a video we had done. Again, a storyboard followed by a video contest where we were able to engage some just remarkable people that build. This is a full 3-minute full CGI video of the RFID system for space station that they were trying to convince folks how it works, and we're having a hard time communicating that. So, coming to the end, I promise, of this part. We basically have figured out that we can do a lot of different things with this and do that. We've done over 700 projects. We typically get success, 94% success rate, and have saved the government about $80 million just using this method. But it turns out, and this is the last section, that we didn't just discover that. In 2015, we found that these crowds weren't just doing contests, that we were tapping into kind of gig crowds as well, and crowds that were doing other things. And what we found really surprised us, which is that there's a big shift going on in the world. And that matching model that we talked about is actually being used with AI to match people and skills to jobs very efficiently. There was a study by Edelman Intelligence that was showing that people were moving to the freelance world at 3 times the rate of regular employment, such that by 2019, over 40% of companies' workforces were non-full-time. In that same study, it showed that by 2027, if these trends kept going, there would be more people in the freelance workforce than in the regular full-time workforce. And if you're hiring people, that's a big shift. And then COVID happened, and everything changed. It all sped up. That was like a 4% decrease and a 4% increase. Just between 20 and 21, that changed and increased by 34%. They're trying to figure this out. They're trying to figure out what's happening here. And one of the questions they asked was, hey, how much money would it take you to come back and work full-time for us? And over 50% said, there is no amount of money that I will take to come back and work full-time. There's a change going on, and it's related to these platforms. And one of the things is lifelong learning. The rate of change is happening in technology so fast that companies are having a hard time pulling in people that actually have the skills, because the more people you pull in, the more you got to either lay off or what, right? And so there's this dilemma that organizations are having. And most organizations, they budget about $1,000 per employee per year for training. And most of that's compliance, like security and safety. So when you go into a company, you're not necessarily going to be learning the cutting edge. In fact, chances are you're not. Freelancers, on the other hand, they know that's the path to the better money. And so that study showed that significantly more freelancers were engaging in lifelong learning than full-time employees. There was a World Economic Forum study that came out in 2020 that said, look, after the pandemic, companies are scaling their remote work, they're accelerating their digitization, they're accelerating their automation. That automation is going to replace people with machines. It's happening at that rate. And they identified 85 million jobs going away. But then they also identified 97 million jobs that were getting created. What's the problem? Nobody knows how to do those jobs. They identified that 50% of all employees by 2025, which we're halfway there, by the way, like that was 2020, 50% would need reskilling, and of their job, 40% would have to change. That training is going to take anywhere from 1 to 5 months. $1,000 per employee per year is never going to do that, right? And so it's this really interesting place where these platforms are starting to actually show that they actually have capability. It's different. I'm not advertising. I'm just telling you it's happening. And this workforce is both on demand and persistent. What I mean by that is it's not that you hire a freelancer once and then you never see him again. In most cases, You hire someone and you go, oh, they did a great job. And you go back to them over and over, and they become your go-to videographer, your go-to algorithm person. And you create this little network. Or maybe they weren't there one day and you had to use someone else, and you don't ever see that person again. And that's okay too. They're available both globally and locally. A lot of people think this is only on a computer somewhere else in the world. But think about Uber. You punch something in and somebody shows up at your door. These crowds are both global and local all at the same time. And they go all the way from grunt work of labeling data or delivering groceries all the way up to nuclear physicists, experts. I went to go hire to use a freelance, and I actually had somebody who used to be the vice president at a major aerospace corporation, and they were freelancing. The capacity is there, and what we're finding is a lot of people who want to learn more, who have a full-time job, will side gig just to make things interesting, right? And they're learning new things. Turns out, by the way, in open innovation, I didn't mention this. In open innovation, it is the one place on a contest where in your life you can try something, fail, and have absolutely no consequences. Think about that. Any other time you get a bad grade or you get dinged at work, but if you really, like, I wonder if I'm a good artist. I wonder if I'm a good mathematician. You can try that out. And if you fail, no big deal. And if you succeed, there's actually maybe a big windfall, and you build a reputation. We actually had a scientist do that once, and she said, you know, my boss never would have let me do what I did here. I actually work in the same area. My boss never would have let me submit this, my PI. Why? Because PI, the folks that run labs have budgets, and they're going to go with the safe bet because they want funding next year, and they want to show progress. But where's innovation lie? It's in the unlikely areas. It's in the not safe bets. It's in the risk. And so that's one of these things you start to get with open innovation. Okay, I'm back to the workforce. These are lifelong learners who are getting that latest tech. You can almost guarantee an organization will have deficits in the latest and greatest skills, but you can always find the latest and greatest skills in the crowd, always, because statistically it just works that way. And these platforms are just getting better and better. We are providing this now at NASA, and we thought, wow, we're going to see if anyone uses these freelance experts, because they're NASA, they're just going to think they can do it. It's caught on like wildfire. People are using it left and right. And I'll just say this about this. As we adapt to the future work, these open platforms are bypassing the gatekeepers, the people that were sitting at the hiring desks and not actually hiring all the best people all the time. There are a lot of people out there that never could pass an interview because they have ADHD or somewhere on the spectrum, but they've got mad skills. This setup is starting. Kelly actually has a branch of a crowd, a community of people on the spectrum, and they're helping them find work through these platforms. Everyone has an opportunity to participate. These organizations need flexible workforces with the changing skills that can adapt and do this, and these workers are increasingly going to have this flexibility and agency to find that work-life balance and pursue it. And we're seeing this after COVID, right? I actually think that in 10 to 20 years, we're going to look back and say, how did we think for 150 years it was okay for companies to own people? Because they own you, right? They own your 40 hours. They own your time. And it's actually not a very efficient model. So diversity is the key to innovation. I just have to say that over and over. And this is my last little bit. You may be looking out in the world and going, this change is not really happening. And I liken it to this stream here. Whereas if you're on this teeny tiny edge here next to the bank and you're facing the bank, it is calm and you're not moving. And you probably haven't moved for a long time. But if you're not careful, you don't realize that everyone's getting drawn out to the rapids that are headed for the waterfall. Like, it is happening everywhere. But that doesn't mean it's happening the same rate everywhere, right? So these changes are happening. So this is my last slide. Open innovation is the future, and innovation is really no longer optional. This capability is getting better and better, and we have to figure out a way to do it, because if we actually want to do these giant leaps, if we want to do this, we've got to find a better way. And so that's what we're doing. Okay, I think I used my full hour. Look at that, 8 o'clock. I am happy to stick around for questions.
We'll get some. Now you know how to make money from NASA, right? You're not freelance stuff. I also have to say this. Some of you have heard me say this because Steve mentioned the word expert a lot. Definition of an expert: X is an unknown quantity, and a drip is a spurt. A spurt is a drip under pressure. So don't call people experts. So, are there any questions in here? I think there's a couple of questions online, Steve.
Oh, okay, great.
Maybe have a look at your
Yeah.
Q&A there. You may just be saying great talk, see you later, but
Let's see, let me get rid of that. Where's precision material located? If you search Steve Rader, NASA, you should be able to find a version of basically this on SlideShare, and there's several videos out there. So it's like 1.5 gig, so I don't, all those videos kind of add up.
I think did we record this particular one? I don't know if I just navigated left.
Yeah, they did.
We
yeah.
are recording this.
Yep.
I don't know if you can hear me online because the microphone's over there, but these are recorded, and a combination of Vaishnavi and Eliza and Ashby, we'll put them on the website, the RSI website, so you should be able to access this particular talk. And then before we go to the next one, Swati, you had a question? You had a question, Swati?
Yes. Hi. Thanks for your talk. It's been super informational, and I'm really excited to hear about this because, so I work for SAP. I'm a technology transitions data lead, and I'm curious if you could talk more about the NASA Target Lab, because Prizes and Challenges is one of our smaller programs, which surprises me. And I was curious if you could talk more about how you measure the impact of these types of challenges in crowdsourcing versus the traditional solicitations that NASA typically has.
Yeah, I want to talk to you after this. We're actually working a lot on trying to integrate into the different STMDs. So Flight Opportunities is now using Prizes and Challenges. How do we measure impact? It's a really great question. We're trying to measure impact in lots of different ways. We're trying to find better ways to study who is participating so we can understand kind of the dynamics in that diversity question. We measure success right now by asking the problem owner, right, who came to us with the problem and say, look, was this fully successful? Everything's done? Was it significant advance, or was it just incremental, or did it provide no value? And that's the 94% means it did at least incremental and significant solved. We also asked them, how much would this have cost you if you had used traditional methods, just internal teams, whatever that. And that's where that $80 million comes from, is they say, oh, this, usually what their response is, this would have been significantly more, and we probably would have never gotten this good of an answer. Not every time. Like this is not 100% success. It's not a guarantee, but it is interesting how reliable we found this method to be, and we're looking to try to track long term, because a lot of these solutions you're not going to know the impact until it's actually flying, and as you know, flight projects take 5-6 years. The speedy ones do. So yeah, it's a great question.
Maybe you can read.
Yeah, let's see. Does it also create equity issues for flex crowd workers because they don't always have solutions? It's a great question. I get this a lot. It's a question about are we paying people fairly? And there's a difference between the freelance world and open innovation. Okay, open innovation is much more akin to a bidding process, like applying for a grant or doing a proposal at work. You're trying something new, and it's, there's nothing making you do that. We don't advise anyone to try to make a living winning prizes. That's just not a good strategy, right? And so that's sitting over here, and people can do that all day long. In the freelance world, people are trying to make a living, and so we're always very careful to make sure that whatever we're paying works out to be a fair wage, and it's a thing. So there are lots of shifts going on in the world in workforce, and fairness is a huge issue of how do we, because think about it, you used to have full-time jobs that were super secure, right? And had all these benefits, and they were great, and you could count on retiring there. But all of that's eroded, right? Now people get laid off on a whim. Their stuff, all their health insurance is kind of more put on them, and we're not geared in the rest of the world to actually see freelancing as a way of doing business. And so the legislature's not there. All the rules aren't there to really get them all of the same things. And so there's these kind of weird shifts going on right now where the world's trying to figure it out, and you're seeing the battles play out. I would just say try to help it along the best you can, because it's kind of the Wild West right now in the transition. Great question.
Is there another one there?
The other one is volume. So I think.
Like the audience
Oh.
to ask first. Is there another one?
Yeah.
Well, please go for the audience first.
Let's see. So David Perla says, it sounds like a community of specialized individuals is ideal for innovation, but how do we know when individuals are too specialized? Should a mechanical engineer study other fields for fun, similar to the solar flare example you mentioned? Like I say, it's about, like, for the greater good, it's a balance. We need experts. We don't need all experts. Diversity is really important, both in your individual studies and corporately. I personally endorse learning lots of different things, because you actually grow a little bit more when you do that. So to me, a balanced education has some specialty and a lot of diversity. In universities, there's a book called Range by, I believe it's David Epstein. He addresses this a lot. In universities, I'm at a university, I have to be careful, have had a hard time, because for many, many millennia, we have been about the deep expertise, and that's the way we have designed our curriculums. And there's a lot of multidiscipline programs that have basically failed because of pressure of nobody likes it. The experts don't like it. There's a case study at Harvard Business School that is taught on the rejection of NASA as to open innovation, because open innovation was new and it was threatening. And in the first few years, the scientists basically said, we're not doing it. And we had to relearn how to talk about it and how to get folks to try this stuff out. Because think about it, it's the most fun part of your job, and you're wanting to outsource it. And that's why we say, look, it's not outsourcing your job, it's getting you the best starting point so you can have the best solution. But you can kind of see how it would be threatening, right?
And you should always study solar flares for fun.
There's one more online, I think, is Jan Sai, which says, can AI replace open innovation? This is the second time this week I've gotten this question. With solutions that ChatGPT that soak up text-based knowledge. It's a good question. AI is definitely coming along. ChatGPT is turning everybody's gears in their heads going. I think that AI is going to play a role, and people are going to play a role for the time being, working more and more together. The future of crowds is actually much more likely that AI will be used to actually match teams of people just right. Think about it. You have a problem. It requires a chemist, an electrician, whatever the skills are. It can figure that out. AI can figure out what skills you need. And then it goes through a crowd of 500,000 people and finds who has those skills. Now, who's worked together before? Maybe half the team has to have worked together before. And who has, who's a 1 Enneagram? I don't know if you're an Enneagram. Who's going to work well together? And I match them on personality types. And then I put somebody that's trained on how to get the most out of a team. in theory, you could put together a high-performing team. And if you've ever worked on a high-performing team, it's the most fun you've ever had because they value your inputs, your value add, and you're doing these amazing innovation things. Now imagine a platform that can, with AI, put together 50 of those teams overnight to work on a problem. That, to me, starts to be where we really tap into what human cognition can add in partnership with AI. Now, will AI take over all the other? That's a whole nother question.
So my question is there, when you're trying to put these problems, is there a maximum level of problem? Like, in other words, how do we get to Mars by 2020?
Yeah.
Right? At some point, that's not a good question to ask.
Yep.
But so
where's the line?
To
Yeah.
the kind of questions where you know you're going to get a decent response and a decent chance of.
That's a great question because so the current state of the art for crowdsourcing challenges is that you're largely, for the money, there's a money aspect to this, but for kind of moderately priced challenges, you're talking about individual solvers. There are some that'll form teams, but you really have to get money up a level to get teams to motivate to come together. And so one individual can know 2 or 3 domains pretty well, but they can't do a whole system very well. They can do little pieces. So what we do is we take system level problems and we'll break them down. So let's just say you wanted a better life support system and it needed to be much lighter than the one you have. Okay, well, let's look at that problem and find what's the heaviest pieces. Okay, it's this compressor. Okay, let's do a compressor challenge and see if we can get a lighter compressor, right? So we kind of decompose the problem. There's a great Einstein quote, I'm sure you use this all the time. If I had an hour to work a problem that my life depended on, I would spend 55 minutes working on the problem or understanding the problem and only the last few minutes trying to solve it. And I think that's one thing we talk about a lot is spend more time understanding your problem before you go attack it. And so we do a lot of that with the idea of what's solvable by individuals. And these companies and curated platforms, they make a business out of that. So they're really good at that. And a lot of times we will use them to help us do that.
That's what I tell my students there. It's not the answers you get, it's the questions you ask.
Yeah, Warren Berger has a really great book called A More Beautiful Question that just dives into that in depth.
So I think we're coming, unless there's, I don't know if there's any questions more online, if there's any questions in the audience here, Charles, and then we'll come up there. So Charles first.
Yeah, just curious. So I'm Charles with AT&T now. I'm fortunate to be part of Accelerate Space
Oh, cool.
at the Human Performance Accelerator. And so I'm thinking about Eric right now. As I go around to different schools, I'm noticing robotics programs exploding, things like that, micro-credentialing, associate's degrees. But a lot of these academic feeder programs are feeder programs for full-time jobs. And so how does this open innovation come down into ISDs, school districts, and prepare students to participate in open innovation and not just full-time work?
Yeah, that's a really great question. Well, I don't know if you know this, but like 5 years ago, Microsoft, Google, Amazon, everyone got rid of the college degree requirement for employment. Did you know that? Why did they do that? Because what you just said, people are able to train singularly and come up. And I think there's a real issue with that because the value of liberal arts is that you learn how to think, right? And I think from a citizen standpoint, it's a really dangerous thing when you don't train people on the broader picture because then they're more apt to be able to be manipulated, right? So there's some serious issues, and universities are really expensive and education costs are really hard. And this is what happens when that situation is in place, is you're going to drive to where people will do the low cost thing to go make money. And you can go take the Amazon or the Google data science class and in 6 months be making $70,000 without a college degree. It is out there. And if you read Competing in the Age of AI by Marco Anciti and Karim Lakhani, it will convince you that every company is going to have an AI factory and that the biggest shortage we're about to have is data scientists. And so all of those are coming fast, and we're going to have to figure it out. Whenever there's something good that technology provides, I always think it's proportional. The better the technology, the more of a dark side it has that you better be looking for and better be addressing. So that's 2 cents from me, not NASA.
Please.
I was wondering if you had a chance to watch the movie Goodnight Hopping, about the 2 probes that were sent to Mars back in 2004. If so, how things you how successful do you think you would recommend in using the solutions would that make the program?
I have not seen that, so now I've got something to put on my Netflix queue. But yeah, no one uses the queue anymore. But I don't. It's hard to know. Yeah, the question was, have I seen the movie Goodnight Oppie, which is about probes going to Mars? Oh, Spirit and Opportunity. Oh, yeah. Okay. Would those have been different? It's hard to say. I think I know people that worked on those programs. They're brilliant people, and they were built almost 20 years ago. Like when they were designed, we didn't have this same compression of change, and so it's questionable whether, if you started back then, how bad was the kind of problem I laid out in terms of the technology explosion and the rate of change. But I think that's what's driving the value, is finding those people that can connect the dots for you. That's a great question.
I can add to that. I mean, the similar challenge, sorry, Jim. The similar challenge is when you think about the Artemis program going to the moon. If we're going to have a sustainable presence on the moon, we have to find ways to work in an extreme environment, not just humans, but the machines itself. And so how do you survive 2 weeks of night on the moon? And you have to address those problems. How do you turn regolith into a functional material that you can use for building and so on? And I think that the way that somebody like me is looking at this problem in part is by, say, talking to someone in the energy industry. But I think Steve would have a different picture now, and I think we've learned that tonight, which is that the solution may already exist for a certain, maybe not for the moon, but maybe for an extreme environment in terms of swings in temperature, for example. And so there is probably a way of designing what we need to have a sustained presence at the moon and then onto Mars that takes advantage. So this is also related to my question about the level of problem you can ask. But when you get the people who can bring it together, they need power, they need to be able to dissociate water and hydrogen and oxygen, they need to get the water in the first place. There's all little bits of that challenge that smart people in multiple fields maybe have a potential solution, and it's up to the experts to actually pick out the solutions that make sense in the broader architecture. So I think there's an organization that NASA's funding out of Johns Hopkins called the Lunar Surface Innovation Consortium. And what they're trying to do is come up with the technologies that enable the science. And they're trying to address all these different areas. Some of them put out challenges like what's on the moon, what being a Scotsman, of course. And so I think there is a scope for that probably that wasn't there with Spirit and Opportunity. And it is a different mindset, and I'll stop there because I think there's challenges for us at universities. Our students want to be multidisciplinary, which means they have to learn a range of skills. But they don't come for free. You need to have some basic knowledge. I don't mean the cost of tuition, but you do need some basic knowledge. If you're going to do physics, you have to understand some physics. Whether you apply it to a physics problem or a chemistry problem or an engineering problem is a different matter. So we have to adjust to that in order to be produce the leaders in these fields and people who are thinkers and so on. So that's a whole interesting talk. So I'm going to finish with Jim, unless there's any pressing questions, but please.
You guys are hardcore. You stay for everything. Like
Thank you so much, Professor Ryder, for your wonderful, wonderful speech. For me, we're standing on hallowed ground here. As you know, President Kennedy.
He means Valhalla.
President Kennedy made his famous speech in the 60s here, and NASA, your organization performed. I'd also like to congratulate you on James Webb. What you have educated me on today has given me tremendous hope for the future for you and your organization. What Sir Alexander has done here is giving me tremendous hope. And you, sir, bringing your son here gives me hope for the future. Thank you very, very much. And I see just a wonderful future. The train has left the station for this crowdsourcing. There's no question. It's just how to do it. You have one of the best jobs in the world.
It is.
Frankly.
It is.
Thank you very much.
Thank you.
And you just saved me from doing my last job. So thank you all, and especially thank you to Steve. It's a real pleasure having you here. Please keep your order mailing list, so we will. I'll keep you posted about it. I'm hoping to have one early March, and then we'll have one in April, and there may be some other things that are coming along the pike that we'll keep you informed of. So thanks for bringing the weather. Thanks for coming out. It's good to see you all again, and good to see the new faces. And we'll see you next time.
Thank you.